Part 8 includes results from my continued battery research, an even better and safer way to power LocoFi and the locomotive using 4 Soshine LiFePO4 batteries. LocoFi in action, moving slowly through 2 turnouts. Useful links are in the description below this video. Results from my continued battery research. Over the past few months, I have continued my research into lithium-based cylindrical battery chemistries in the sizes that are useful for HO power. My investigation included mostly the 10440 size lithium-based cylindrical batteries that can be used in 2 AAA battery boxes, whether modified to 3 in series or using all 4 in series. Previously, I recommended the IMR Lithium Manganese Oxide, LMO, cylindrical batteries in a 10440 size for both its power ability and relative safety when used in a 3 in series resultant battery, 3S. My current research has indicated that an INR, lithium nickel manganese cobalt, NMC, in the 10440 size might also be useful and as relatively safe as the IMR type in a 3S resultant battery. I have not tested this type of battery chemistry yet, but it looks promising. Recently, I have fully investigated the 10440 size lithium iron phosphate LiFePO4 IFR batteries. The resultant battery uses 4 of these 10440 size batteries in series 4S in 2 AAA battery boxes in a trailing battery car. Because of this research, there is now a lot of new and revised information on my HO webpage, including possible battery and charger choices, the procedure to determine the actual runtime using 3 IMR or 3 INR 10440 size batteries, the procedure to determine the actual runtime using 4 IFR 10440 size batteries, and the CSX with the Boxcar battery car converted to LiFePO4. The derived runtime procedure has been eliminated, so determining the prototypical actual runtime is now a single step. The CSX with the Boxcar battery car converted to LiFePO4 batteries. Why? The Walthers EMD GP15-1s are running perfectly well using 3 EFES Lithium Manganese Oxide, IMR, 10440 size batteries making up the resultant 3S battery. The IMRs are relatively safe, but I knew that lithium iron phosphate batteries were even safer because that is the type of battery that I use in the vast majority of my electric-powered RC airplanes. Lithium iron phosphate LiFePO4 batteries are the safest of the commonly available lithium-ion-based batteries. They are also known as LIFE, LIFE, LFP, and IFR. IFR stands for lithium ion, F for the chemical symbol for iron, Fe, and round, which really means cylindrical. To verify my safest claim, use the 2 links in the notes below this video. Lithium iron phosphate batteries have a nominal voltage of either 3.2 volts or 3.3 volts, depending on the manufacturer and the exact chemicals used in the manufacturing process, instead of the nominal 3.6 volts or 3.7 volts of other commonly available lithium-ion batteries. That means that 4 lithium iron phosphate batteries must be used in series instead of the 3 IMR batteries. That is not a problem, as the battery boxes hold 2 batteries each, for a total of 4 batteries in series. The goal was to exchange a bit of prototypical actual runtime to use the safest possible batteries. After testing, it was discovered that no prototypical actual runtime was given up, as the prototypical actual runtime for this locomotive using 4 of the Life batteries was identical to using 3 Lithium Manganese Oxide IMR 10440 size batteries, 45 minutes. The rear, modified battery box of the Boxcar battery car was changed out for a new battery box with its wings removed, so that a total of 4 IFR 10440 size batteries could be used to create a resultant 4S battery instead of 3. An old, never used anymore soldering iron and a pair of needle nose pliers were used to remove the battery box wings instead of a Dremel tool with a sanding drum. It worked well and seemed somewhat easier. A set of 4 SoShine 10440 size 280 milliamp hour lithium iron phosphate batteries were ordered from Amazon. The locomotive was reconfigured for use with the 4S 10440 size IFR resultant battery. The step 7 speed was 74 miles per hour, and it was set to limit the top speed to 65 miles per hour, the top speed for the GP15-1. 2 actual runtime tests, as described later, were performed. Both of the test results showed that 45 minutes of prototypical actual runtime was possible. I feel that this is the best and safest conversion that I've done so far using LocoFi, even though it costs a bit more because it requires a charger that can charge LiFePO4 batteries. For those still concerned with runtime, I have a section on my website that covers this topic. It is called How Long is a Typical Operating Session's Runtime? After I did this conversion and completed testing of the IMR and IFR batteries, I made some big changes regarding how to evaluate the runtime. The sections on my website titled The Procedure to Determine the Actual Runtime Using 3 IMR or INR 10440 size batteries and The Procedure to Determine the Actual Runtime Using 4 IFR 10440 size batteries explains how to test for the prototypical actual runtime. A Deadrail update. Recently, LocoFi updated their forum so that there is now a forum dedicated to the topic of Deadrail, battery on board. It is called battery/Deadrail. The link is noted below. To close out this video, there are 3 short video clips showing what LocoFi and battery on board do best. The Walthers Trainline GP15-1 with its Sioux Boxcar trailing battery car with 4 SoShine 10440 size LiFePO4 batteries is shown moving slowly and steadily through 2 switches with no glitches. I suggest that my website should be checked at least on a monthly basis to see what I've learned, relearned, and where I'm going next with this project. My email address is linked at the top of my webpage if you have questions to ask or comments to share.